everyone, this is Ms. Fazone, and today we're going to be talking about factoring completely. Prior to this lesson, we talked about factoring using GCF, factoring using a chart, product sums or multiply combine, and difference of two perfect squares or dots. So make sure you learned those before we jump into this. Alright, so I ask this on every slide, what is factoring? Because it's this general term. Factoring as a verb means writing a polynomial as a product. So it's stuff where we're double or multiplying like that, or we have something times something with a distributive property. Another way of thinking about it is reverse distributive property. Right? We learned to distribute, now we're learning to write it as a product. Okay? It's important to know what those directions are, because when we're factoring, it's very vague. You need to know what the teacher or the problem is asking. Alright, what does it mean to factor completely? So think about completely. Completely means all, right? All the way. So factoring completely typically means factoring more than once. Typically, when we factor completely, not 100% of the time, but most of the time, you're doing your GCF first, and then you're doing either your difference of two squares, or your product sum. So whenever we're factoring, we should automatically look for our GCF before we do anything else. So with factoring completely, usually we do GCF, and then we look at what's left, and we'll have another kind of factoring that's left for us to do. Okay. Pause the video, write this down. Alright, so we're going to factor this polynomial. So when we look at this, think about some things. Think about how many terms does this have? Well, it has 1, 2, 3 terms. It's a trinomial. When I see a trinomial, I kind of jump to, oh, this is product sum. This is not product sum right now. Why? There's a number in front of x squared. It has a coefficient. If it has a coefficient, you cannot do your product sum chart. But notice that 3, what can we do? We can divide everything by 3. So we have our GCF of 3. So I'm going to divide. 3x squared divided by 3 is x squared, plus 30 divided by 3, 10x, minus 24. Now remember, when you do a GCF, parentheses, GCF on the outside. Now we're going to look at what's left. Look at this inside. Now this is our product sum. This is our trinomial with a coefficient of 1 in front of x squared. So we're looking for two numbers whose product is negative 24 and whose sum is 10. Now this is one of my favorites because students get it wrong all the time. I don't want you to get it wrong, but I like giving it to you to make sure you're paying attention. So a lot of students for these jump to that 4 and 6. But I always tell them, write down everything that multiplies to 24. Since we're multiplying to a negative, we need one negative. So a lot of students jump and they're like, oh, well, 4 and 6 gives you 10. But notice, since we're multiplying to a negative, the 4 is negative, and that doesn't give you 10, it gives you 2. But over here, the negative 2 and 10 does give you, negative 2 and 12 does give you 10. Okay, so find which pair gives you a sum of 10. So those are my two numbers. So I'm going to factor my trinomial, x minus 2 and x plus 12. And don't forget to keep that GCF in front. And that's factoring completely. We factor using a GCF and then our product sum. Alright, here's our next one. Similar idea. Look at this problem. What does this look like? Again, it has three terms, so that product sum jumps out at me. But how is this one different? Notice every term has an x. So what's our rule for the GCF using x's? Whichever has the smallest exponent. So we're going to do a GCF of x. X to the first is the smallest. Divide. Subtract your exponents. Last term it cancels out. And again, we're left with a product sum problem. Where our product is negative 6. Our sum is 5. Not very many things multiply to 6. 1 and 6, and 2 and 3. Since we're multiplying to a negative, I need a negative. Oops, it's a negative 5, just kidding. Since our sum is negative, our bigger number needs to be negative, using our sign number rules. And so this gives me my negative 5, so it's positive 1 and negative 6. X plus 1, x minus 6, with my GCF on the inside. And we're done. Alright. Oops. Pause the video and try this one on your own. It is a little harder, or both of these actually. It is a little harder, but I have confidence. We're smart, we can do it. Alright, so for number 3, again, this is not something we can do right now, so we need a GCF. What's the GCF? Notice that 4, typically it's whatever number is in front here. So 4, but then we have x's, so what's the GCF of the x's? Just plain x. Divide, let's see what we're left with. 4's cancel, so x squared. Plus 64 divided by 4 is 16x. Minus, what is that? 36. Parentheses, do not lose your GCF. A really common thing here is students get really focused on their product sum, but they forget their GCF. So my product is negative 36. My sum is 16. 1 and 36. 2 and 18. That 2 and 18 is going to give me 16. Now, who's going to be negative? Since my sum is positive, my smaller number. So those are my two numbers. X minus 2, x plus 18, with my GCF on the outside. And we're finished. Alright, number 4. This one's a little tricky. 50x squared minus 32. So this has a GCF. We can divide. Is x part of our GCF? No, because we only have that x squared. There's no x over here. So it's just going to be an integer. So what goes into 50 and 32? The only number that goes into both is 2. Divide, and we get 25x squared minus 16. Now look at what's left. Is this product sum? No, it's a binomial. This is your difference of two squares. I like to call it dots. Two perfect squares separated by subtraction. So whenever you have the difference of two squares, it's think square roots. What's the square root of 25? 5x, 5x. 5x times 5x is 25x squared. What's the square root of 16? 4 and 4. 4 times 4 is 16. To have that minus and that middle term cancel, they have to have opposite signs. One's a plus, one's a minus. And don't forget to put that 2 in front. And we're done. All right, pause the video. Here's 4 problems for you to try on your own. Now this first one, I love giving this. I put this on tests a lot, to be honest. Because it looks like a dot. It looks like the difference of 2 squares. But it's not. Think about it, why? That is a plus. When you have a plus, it cannot be dots. It's not allowed. Difference is, you can't do that with real numbers. If you get to higher level math, we can factor this in higher level math using imaginary numbers, but we're not worried about that right now. So it's a binomial, it's not dots, so it's a GCF. What's my GCF? 4. X squared plus 9. Can we factor it again? No, this actually isn't even a factor completely, it's just a GCF. So be careful. However, the next one, number 6, that one has a subtraction. So that one we're going to be able to factor twice. Again, I only have x squared here, there's no x's. So my GCF is a plain integer, 10. Divide x squared minus 9. Since it's a subtraction, I'm able to factor the difference of 2 squares. What times itself is x squared? X and x. What times itself is 9? 3 and 3. One's a plus, one's a minus. Bringing that 10 down in front, and we're done. You can put a minus and a plus. I just happen that just the way I always work, I always put plus minus, but it doesn't matter. All right, number 7. Getting a little harder, but honestly, it's really not that difficult. If you can figure out your GCF, you're good. So I always start by looking in the front. 3. Does 3 go into everything? It does. So 3. And then I have x to the 4th, x to the 3rd, and x squared. Take your smallest exponent, x squared. Divide x squared. We subtract. 4 minus 2 is 2. Minus 12x plus 20. Parentheses, 3x squared on the outside. And then, let's see, what multiplies to 20 and adds to 12? 10 and 2. 2 times 10 is 20. Now, since the middle term is negative, they both have to be negative. A negative times a negative is positive. And that's the answer. Last one. What's the GCF? Look at that first term. 2 goes into everything. Is there an x? 36 doesn't have an x term. It's a constant. So we can't do that. So we get x to the 4th minus 7x squared minus 18. This is not factorable, is it? 9, oh no it is. 9 and 2, just kidding. Yeah. Okay, so now this is a trinomial, nothing in front of x squared. This one's a little tricky. We want it to be x, negative 18 is 2 and 9. So 2 and 9, my 9 has to be negative. But notice we're not multiplying to x squared. X times x is x squared. That's x to the 4th. It's x squared and x squared with a 2 in front. But there's more. I feel like I'm in an infomercial. There's more to do. Look at what we have left. We have a 2, x squared minus 9, x squared plus 2. What can we do to x squared minus 9? That factors again. So we have our 2, x plus 3, x minus 3, because this is a dot, it's a difference of 2 squares. And then that x squared plus 2 is just chilling. So this one's pretty tricky. But again, just follow your steps, do your GCF, look at what's left over. Oh, it's a product sum. Just go step by step and really pay attention to what you're doing. All right, last one. This is a tricky one. I actually cannot off the top of my head remember the GCF. I think it's 4. Let's try 4. And if you're never not sure, just try stuff. Use a calculator. I don't have a calculator on me, but I know 4 goes into it. 4 goes into 32. 8, or goes into 81, that's positive. All right, and 24, that's 6, 25. Oh, and those are both perfect squares. We're left with the dots. Parentheses, 4 on the outside. So now I have the dots. What times itself is 81? 9x squared, 9x squared. X squared times x squared is x to the 4th. 625 is 25. 25 times 25 plus minus. We done? Or not? Now which one? Only one of these will factor. Think about which one is it? The one with the minus, right? Difference, subtraction. That plus, you can't get that in those negatives to cancel. That middle term won't cancel. So we can do this one now. What times itself is 9x squared? 3x times 3x is 9x squared. What times itself is 25? 5 and 5. One's a plus, one's a minus. Bring everything else down. If you can do this, you are pretty awesome. So that's factoring completely. Start with your GCF and then always check what else can I do. Can I do a dots? Can I do a product sum? Can I do another GCF? Maybe you didn't get the GCF the first time. Right? And that's it. Hope this was helpful. Have a great day.